I'm very happy to be with you today. What a great event. We talked about Moore's Law this morning. I remember when I first learned about it when I was studying engineering, computer science, and telecommunications at university. And back then, that really struck me how the founder of Fairchild and Intel came up with that law, predicted that computing power would double every 18 months in the future. And actually, that happened. And that still verifies today. We'll get quantum computing in the future, obviously. And that explains some of the incredible progress and innovations we've heard about during this event, during these past 2 days. So I guess we should all feel very optimistic about the future, right? Well, I am to some extent, because the thing we need to consider is that technology is not the only thing which is accelerating at exponential pace. This graph shows some of the, how the footprint of humanity on the biosphere has been increasing exponentially since the 50s. Every year, we use and consume more resources than the Earth can provide, and the time where this date of overshoot happens comes earlier and earlier every day. We are almost exhausting our carbon budget. The carbon budget is basically how much carbon we can emit, how much greenhouse gases we can emit to stay under the limits of the Paris Agreement. And depending on studies and scientists, for the 1.5 degrees target, it's somewhere between 2 and 10 years, roughly. And obviously, the population is increasing and so on. So you might say, OK, maybe a difference of 0.5 degrees is not so much a big deal. The only thing is that it's not only humans emitting greenhouse gases, it's also the Earth. We have complicated and complex carbon cycles, which have stabilized over the years. And every 0.1 degrees above 1 degree has a risk of hitting tipping points where we will destabilize this cycle, and we could have dangerous feedback loops where places like the permafrost, for instance, could release even more greenhouse gases and lead us to extreme level of warming. This has dramatic human consequences. I'm quite puzzled that today the EU has a hard time to divide 58 refugees between its member states, and I'm really wondering how it will perform when we'll have hundreds of millions of climate refugees who will flee sea level rise, drought, and extreme weather events. This graph, it's from the Global Challenges Foundation, a very serious Swedish foundation that works with some of the best labs at Oxford and Cambridge, studying the risk, existential risk for humanity to potentially be at risk on this planet. And this is the probabilistic repartition of how much warming we might hit in the future. As you can see, it looks pretty bad. So, and actually, I'm very surprised because last week, this kind of information doesn't only appear in environmental magazines and in academia, but even Bloomberg starting to report on this and the potential extreme climate change we might be facing and how to adapt to it. So I know this is not the kind of conversation you would expect from an event about exponential technology and that's supposed to be optimistic about the future. I think it's very important to be aware of what is at stake and to realize that basically we're in a place where we have two choices. One is to be pessimistic or realistic, or I don't know what's the right word for that, and continue on business as usual, maybe with some marginal or incremental improvement, like 10% efficiency here and there. And basically, maybe it's a recipe for disaster. On the other hand, we could do what humans are good at, which is to reframe this massive challenge into the biggest opportunity, the biggest innovation opportunity in our lifetimes. So if you remember Moore's Law, what was really fun about Moore's Law is that it was never based on any physical constraints, any natural parameter, any legal constraints. It was a heuristic. It was the industry that just came together saying, you know what? We are going to do this. We are going to double every 18 months, and that's pretty much what happened. So that was a golden rule for the industry to follow. So what if we came up with another golden rule? So enter the carbon law. The carbon law is like a roadmap that was built by some of the world's most prestigious climate scientists that say that if we want any chance to stay under the limits of the Paris Agreement, we're going to have the carbon emissions that need to peak at the maximum in 2020, and then fall dramatically every 10 years to be halved every 10 years until 2050, while at the same time we double the capacity of carbon sinks, natural carbon sinks, and artificial carbon sinks over the same period. And if we do all that, we have roughly a 66% chance of staying under the 2 degrees Celsius target of the Paris Agreement. And to achieve that, we need no less than a complete moonshot, and we need to invent a new carbon economy. A new carbon economy, it's an economy, prosperous economy, growing economy, that captures more carbon than it emits and sequesters more carbon than it emits. So technology and science is obviously a powerful enabler for that. So you can think, for instance, of how we can increase natural carbon sinks. So reforesting, restoring the biosphere, and you have super interesting companies that use drones to do mass-scale reforestation, replanting 1 billion trees per year, using algorithm to determine the optimal planting pattern and replanting trees at industrial scale. You could find a way to support farmers to do carbon farming. Carbon farming is a practice where basically you sequester more carbon in the soil of your farm than you emit. You have companies like Nori, for instance, they propose a cryptocurrency and blockchain-based system to make a marketplace where you can invest and support and incentivize farmers to do carbon farming. And they want to apply that to any kind of carbon removal, including also direct air capture. You have a super interesting project in Switzerland called Climeworks, where they capture carbon directly from the atmosphere to store it in the soil, in minerals, and many other applications, and many potentially in carbon negative materials. And maybe, and not maybe, there's actually a lot of companies working on that right now to develop a new economy where you have value-added materials like for construction, for consumer products that have a negative carbon footprint, like this facades material that you see on the screen. But it's still not enough, because it's a good thing and it's mandatory to reverse climate change, but at the same time, we need to deliver prosperity to the world, because today we already have so many people that die of hunger, that don't have access to clean water, that need education, like Volker mentioned in the previous presentation. And 3 years ago, the UN came together to agree on what are the biggest challenges that humanity needs to focus in the future. Climate change is one of them, obviously. But these are the 17 UN Sustainable Development Goals. And basically, finding a way to be between the planetary boundaries of climate change and other factors, and providing these social foundations for people to thrive upon, it's what economist Kate Raworth called the donut economy. It's like this safe limit we want to be in, where we need to be between this limit, basically. So last year, we created a company called Good Tech Lab. We are a research company. We are focusing on exploring how science, technology, and entrepreneurship can help us to build this new prosperous future. We've been doing interviews with entrepreneurs, venture capitalists, accelerators, incubators, corporates, universities, and we're going to release a couple reports, first one in November, sharing all the findings of this space, what are the biggest opportunities, and the people already working in that space today. So let's take one example. If we take food and agriculture, we talked a lot about food and delicious gastronomy this morning. Our agricultural system today has already a hard time to feed 7 billion people in a sustainable way. It's already highly unsustainable for many reasons, shown on that screen: deforestation, climate change, the soils are being depleted, and many other issues. So how are we going to feed the 10 billion people that are going to populate this planet in 2050? That's, I think, one of the biggest questions we need to tackle, obviously. So there's a few issues we can work on. For instance, tackling food waste. Roughly 1/3 of the food produced today on this planet is being wasted and thrown away. That's a huge waste and a huge source of carbon emissions and soil depletion. So there's a few companies that try to tackle the two places where that happens. That happens between harvest and retail, and that happens at the retail and consumer level. Post-harvest, companies are developing, for instance, bio-based thin membrane and edible membranes that you can wrap fruits and vegetables with in order to improve shelf life. At the retail space, you can use data artificial intelligence for stores and retailers to do procurement in a more efficient way and to predict when their stocks are going to end up, and to adjust in real time the pricing of their products to avoid waste at the minimum. Another important issue to tackle is removing animals from the food supply chain. Today, animal farming is the single biggest contributor to the negative impacts of agriculture for land use, deforestation, and many other problems. For people who are vegetarians, like myself, there are already a lot of options, like plant-based products, meat substitutes, and so on. But how are we going to deliver meat products for people that really crave for meat because of cultural factors, because of habits, and because they aspire to middle-class living like a lot of us have today? So the clean meat sector and the cellular agriculture sector is one of the most interesting sectors we're seeing today. There's a lot of companies from Silicon Valley, from Europe, trying to reproduce meat at the exact molecular level, but without having to grow that in the form of an animal. So it's a similar process as brewing beer, if you will, except a little more elaborate. And you could recreate like a burger, sushi, dairy product, and pretty much anything. That's one of the hottest sectors in technology today. You have investors like Bill Gates, Richard Branson, Leonardo DiCaprio investing in these kind of companies, and I think we're going to see a lot of that in the future. Last one, how do we phase out chemicals, synthetic fertilizers, and harmful pesticides from agriculture? You have a lot of super interesting companies that try, for instance, to harness the microbiome, like the bacteria and the biome that are, and the microbes that are already present in the soil and in the plants, in order, for instance, to increase their natural defenses against pests and diseases, or to fix nitrogen from the air directly in the plant without the need for nitrogen fertilizers. These few companies and these few sectors are only just a few of a global trend that we observe, which is this convergence between tech and science-based entrepreneurship and impact entrepreneurship, impact investing, and so on. And we see tons and hundreds and thousands of companies targeting these massive problems. And the reason why we think it's extremely important and we are hopeful for the future is that it's not only that the technology and science is there, it's also that there's a huge market for it. And we believe that market forces will be key into making that happen. There are some very serious studies, for instance, from the Business and Sustainable Development Commission, which includes Unilever and many other companies, that achieving the Sustainable Development Goals is going to be a $12 trillion, with a T, million dollar opportunity from now to 2030. And similarly, delivering climate solutions that can remove 1,000 gigatons of carbon from the atmosphere has a net economic gain, that's revenue less cost, of $45 trillion, according to drawdown calculations. And I think it's really interesting to look at some economists what the economists have to say about that. And there's two economists I really like, Carlota Perez, who wrote a book who's actually probably the Bible for most technology VCs today, which analyzed the link between technological revolutions and economic cycles. And basically what she says is that the 5 main economic cycles that happened since the first industrial revolution share a similar pattern. You have on one side first a phase of bubble-driven prosperity with the introduction of new technology. Then you have a big crisis in the middle. And then you have a golden age that's fueled with the maturation of this technology and its applications. And she argues that today we are at a similar time. We just get out of the economic crisis fueled by the 2008 financial crisis. And we need to invent what she calls smart green growth that's going to bring us to a new golden age. Her colleague, Mariana Mazzucato, who wrote a book called The Entrepreneurial State and the Value of Everything, for instance, recently published and handed over a report to the EU Commission called Mission-Driven Research and Innovation, where she makes the case that the government needs to help shape and give a direction for innovation, like we had for the Apollo program, for instance. We want to get on the moon, or we want to win the Cold War, or we want to build roads and infrastructure. Well, we need to have the government to say, we want to solve climate change, we want to solve the global goals, and to put in place all the right incentives, research funding, and everything that's needed to get the private sector up to speed. And there's already, as I'm talking to you, a lot of investors, technology impact investors that are investing in this kind of companies. They have different approach. Some of them come more from a tech culture, others come more from an impact investing culture. Some of them are very focused on a sector. Some of them are generalists. But there's a tons of opportunities, and these investors are tackling these opportunities today. I want to leave you with one final thought, which is we're super optimistic of the future, but we shouldn't fall into the trap of what some call techno-solutionism. It's not like a blind faith in technology and science alone that will save us. It's a complete mindset shift, behavior change, and it's a complex approach to problem. Understanding the system you want to tackle, what are all the stakeholders, and what are all the issues in the system and the sector you want to tackle. And being aware of what are the potential negative effects and consequences of technology and mitigate these negative consequences, like threats to democracy, for instance, or autonomous killer drones, for instance, or even understanding that digital technology and clean energy technology, they rely fundamentally on physical resources, like metals and minerals, and some of them are in very, very limited supply, rare metals and rare earth, and we're going to exhaust some of them. Some of them are being controlled only in China, or there are some in Sweden, etc., or in Chile, but it's a very critical problem. And also, most of these metals, not most of these metals, but some of them, including coltan and tantalum, are being mined in disastrous conditions in places like Democratic Republic of Congo, for instance, and we don't even know how to recycle them properly. So we also need moonshots and radical innovation on the mining and circular economy process of electronic and clean tech. So technology has a lot of challenges, but it also brings so many opportunities, and I think that every one of you in this room, you hold part of the key that can help us to avoid the catastrophe and to lead us instead to a state of global shared prosperity for the whole world. So I invite you to get interested in this kind of projects and companies and technology, to invest in them, to launch new companies, and I think we're going to need, in the future, tools and compasses to evaluate what are the potential impacts, or positive impacts of such technological developments, knowing what are the risks, mitigating the risks, and moving forward altogether. So if you're interested in all this, you want to know more, you're working on impact management for technology or some revolution that can bring a better life and better world for everyone, please come to us. We're very happy to speak with you, and you can register to get a free copy of our report when it comes out. Thanks a lot for your attention, and have a great day.